Hi, I'm Dan Rickards. I'm Head of Cloud Strategy here at Telefónica Tech, and I'm really glad to be joined by Keith Nielsen, CEO of AppFactor, to have a conversation around application modernization. What is it? Where are people going wrong? And why should IT leaders tackle it moving forwards? Keith, thank you so much for joining me.
Thank you.
Just to start with, do you just want to give us an overview as to who you are and your journey with AppFactor today?
Yep. Yeah, sure. Look, first, thanks for having me. It's a pleasure. I'm the CEO and founder of the business. We're really focused on helping organizations optimize the process of software maintenance, be it kind of adaptive and transformational in terms of that modernization. And so we've been building a product that helps organizations optimize and automate that process along the journey and make this a continuous motion to really help organizations clear backlog and focus on the future.
Yeah, brilliant. I think application modernization is one of those things where so many organizations have applications that they know they've got problems with, but they're just never quite sure where to start, how to start, or what to even do. And I think one of the massive challenges I've seen from a lot of the organizations we're working with at the moment is they've got a massive application visibility challenge. They know that they have this app that they're running and people are using, but they just have no technical documentation. They've got maybe the owner or the person that built it has left the business, and it's just a big black box of code and modules and features, and it's maybe running a really critical business process, and they've just got no way of tackling it and actually shining a light into the application and understanding, okay, that code needs that other code to actually collaborate and work together. You can't execute this without that dependency.
Yep.
Okay, so if we're going to modernize it, how do we start maybe driving domain-driven design to isolate functions or pieces of code and then start containerizing them or making them slightly more modular and stuff. Is that something you're seeing as well from a challenge perspective?
Yeah, for sure. The crux of this is that it's an incredibly complex problem.
Yeah.
I think it manifests itself in a number of ways. The key word being complexity, right? And another key word being scale. The reality is that most organizations don't just have a single application. Yeah. And that really poses a greater challenge because for as complex as this problem really is, and it operates in multiple areas. You talked about documentation and challenges around maintaining that, and in some cases it's missing, but it's coupled with the fact that there's so many applications often in a portfolio that you can really suffer with sort of analysis paralysis. There is an inherent lack of understanding and visualization, awareness of where dependencies are, how applications are performing, where there's interdependencies between applications. And then when you start to unravel, and if we were to just pick one application, you touched on some challenges around things like missing documentation. But in actual fact, there is a kind of hidden element to this which poses a real problem, which is risk. Yeah. And risk is increased when there are things like missing documentation, or there's maybe just a huge dependency on one expert. Maybe they left the business. Irrespective of that, whether they're present or not, that generates a huge amount of risk in terms of being able to move the application forward. Yeah. And applying newer technologies, emerging technologies to existing software that was built in a point in time. So knowing what the status and posture is of an application, and how that can evolve into what. These are kind of underlying questions that take a lot of time to process and understand, and that's really without even delivering the work. And so, that's where there's inherent challenges around understanding what the art of the possible is and what should actually be done. All real challenges.
You can't modernize what you can't see, right? If you can't even see your application, you can't even understand the code that's running, you can't even understand the infrastructure it's running on. The amount of times I've tried to help organizations with their application sort of portfolio, and they're lacking basic things like actually being able to map from an on-prem perspective, mapping servers to applications. They know they've maybe got 1,000 VMs running, and you ask them, okay, well that P1 critical application that does a really important business function, what servers is it running on? And they're like, well, we know it's that one, and we know it's that one, and we think it might be connected to these. It's like there's maybe it's more of an on-premise challenge more than a cloud challenge. But there just seems to be sometimes a massive gap between the infrastructure team running the platform that supports it and their version of success, which is a resilient platform.
Yeah.
And then you have the application team, or maybe the business team, and their version of success for that application is something completely radical. And it's you can't modernize what you can't see. So it's so important, that first step, to create situational awareness. Go, okay, well, what is the problem we're facing with this application? Is it a runtime problem? Is it a performance problem? Is it a cost problem?
Security.
Is it is it a security problem? Are we exposed because of this application? Has it got unknown network connections where potentially malicious actors could get access? And from a security posture, we just have no visibility of our portfolio.
So key, like you say, that initial understanding and trying to maintain that understanding is a challenge in itself. It's obviously one thing that we help focus on. But with that data, with that understanding and that knowledge, comes capability, so that you can start to be aware of the posture of an application, its infrastructure, the dependencies, the underlying libraries. Now, one interesting thing that you talked about there was, the concept of going from on-premise, traditionally, much slower moving, less dynamic. We would go and build and provision infrastructure to last a certain amount of time. Obviously not that efficient, because you would kind of have a buffer of a ceiling in terms of capacity, and you knew that. Obviously, the journey to cloud is nothing new anymore, but one thing's for sure is that cloud actually is way more dynamic. So actually, when you really assess the situation with technical debt, we're looking at something that's naturally incurring debt faster. The environments are far more dynamic. We're able to spin things up and spin things down. There's ephemeral environments. All of this poses an even greater challenge in terms of that awareness and observability. Because that sliding scale of performance, security exposure, the way that the code's been architected, the way that we're building code, the way that the speed in which we're delivering code, that velocity of change is much faster. And now, obviously, that's coupled with newer technologies, and that's coming to us faster still. So this challenge around technical debt is, inherently applied, obviously, to older systems, older environments, but it's newer systems, new environments are just as exposed.
Yeah.
And it's trying to map all of that together into a single view, that we could then understand where we have security concerns, where there's opportunities to optimize a code base, where there's opportunities to re-architect, to standardize on our stacks, so that we can make things more maintainable for the future.
No, definitely. I think on the cloud migration piece as well, maybe 3, 4, 5 years ago, the standard mantra was, if you've got an application portfolio and you're going to migrate that over to the public cloud, you're probably going to look as a rule of thumb, 80% of those apps are going to be rehosted. The ones that will be migrated, 80%, probably just going to be rehosted. Yep. You're just going to lift and shift, put them onto cloud, and only 20% you'd maybe fundamentally look to re-platform or re-architect or rebuild
because it needed to.
Yeah, because there's a business need to do so. And I think, especially now with the advances in sort of AI and tooling maturity and automation capabilities, a lot of the cloud migration journeys that we're seeing now, I would probably say that percentage split has almost hit the 50-50 point, where you can actually modernize apps onto cloud so much faster now than it was capable previously. I think when Netflix first modernized their application onto AWS and containerized it, that project took them nearly 7 years to do. And I think, imagine how much faster you could now do that if at that time you had the tooling capability that was as feature rich as it is now.
Sure. Yeah, I think that key word is journey. I think cloud migration traditionally was about trying to get some early wins and show some success and build the business case for the future. And naturally, we were looking at what can we move faster, how can we demonstrate that win as quickly as possible. The reality is, though, that we're now needing to optimize those workloads. And you're right, there was a good percentage of applications that couldn't be lifted and shifted because they were in poor shape. They perhaps had vulnerable code. You didn't want to move that to a new shiny environment. Maybe there were frameworks or libraries that were just not compatible and not supported. Required a lot more thinking, a lot more work, a lot more manual effort and refactoring, frankly. And so quite often, typically what you found is that those applications were kind of cast aside, and we would deliver success, right, and we'd get some stuff running in the cloud. And I think what's happened now over time is that migration story has really evolved. Now we're talking about modernization. Now we're talking about two streams. One is, how can we optimize what we originally moved, that we've started to evolve in conjunction with our greenfield native development that we've been building in the cloud with? And that's ripe for things like cost optimization. But obviously, really where we're focused is architectural optimization, runtime optimization, code base transformation. How can we standardize on more modern versions of the language? How can we remediate the underlying libraries and optimize newer runtime environments like containerization, serverless capabilities, etc. But equally, those applications that couldn't make that journey, they're ripe. And obviously ourselves, we leverage newer technologies to try and optimize this and accelerate the process, deliver more value, and expedite that process in terms of moving applications into the new world, to harness AI and to harness new cloud runtime technology.
It's something I try and bang on a lot about internally, is that for me, we're sort of in that whole post-migration era of cloud. I think, as you said, a cloud migration is nothing new.
Sure.
It's a well-trodden path now. People know what success looks like. They know what to do.
Yep.
We're now, at that 80-20 split of applications that have been rehosted. For me, I want to be looking at those applications that originally were designated a rehost pathway, that are maybe running on VMs on cloud or running on traditional databases.
Right.
We're never fundamentally re-architected for cloud. They're not a cloud-native application.
Yep.
They're not replicable. They're not stateless. They don't treat environments with
not optimized.
They're not
for cloud,
optimized, right? Exactly. So what are we going to do now with those? How are we going to continue that modernization journey to make sure modernization isn't just a one-time activity, but it's part of our engineering mindset or culture, where we are continuously looking for optimizations or efficiencies or innovations to push into our application estate. And I think this is a challenge I see a lot with some of the CTOs that I work with, is that they've maybe got a really premium technology stack, and they have, if you were to look at Gartner's quadrant, their tech stack is top right-hand corner. There's nothing wrong with it.
Sure.
But fundamentally, their teams are still stuck in that cycle of tech debt where all they're doing is just fighting operations and maintenance issues. They're spending all of their time bug fixing, patching, fixing breaks.
Right.
They're not actually pushing out efficiencies or innovation into the application.
Right.
And so you might have a really highly skilled team, but the work they're doing is almost like the cloud responsibility model, where they're doing the boring, undifferentiated muck of application
taking a huge amount of time.
Not the innovation and the efficiency stuff. And it's like, okay, how do we break that cycle? How do we enable your teams to be able to move faster but in the right direction? And so I have a big bugbear against people that tell me our teams ship so fast. It's like, speed is not, for me personally, I don't think speed is the answer. It's like, you can be running at 100 miles an hour, but if you're running in the wrong direction, you're just going to make the problem worse, right? And so how do you sort of break that cycle from an application modernization perspective, where the tech architecture is premium, it's cloud native, it's shiny, but the team is still just not getting any value from that application? I think that's where, as you said, like, modernization isn't just a one-time project. You have to build it into the DNA of your engineering teams. So they really take it seriously. And then fundamentally, you look at your operating model and your ways of working. And the same way you've got cloud-native services or components, the way you're working as an engineering team is also cloud-native.
Yeah.
Otherwise, you're not going to get the benefits of modern engineering principles.
Agreed. I mean, look, the key point here is that developers, and there's lots of studies, there's a Stripe coefficient study that said over 33% of engineering's time is spent maintaining, keeping the lights on effectively, performing sort of adaptive routine maintenance tasks, from bug fixing, code smells. Applications still have dead code, or they generate dead code as features come in and features come out. So, that's a huge amount. There's over a third of engineering time that's spent just keeping lights on. And that traditionally what we've seen then is that a lot of transformational initiatives that you want to do to move things forward, to adopt newer technologies, to optimize an application, improve its posture and health, have been perceived as very project-based, often very costly, lots of resource required, lots of time required. And that's where I think there's a real opportunity to harness a lot of AI approaches like we're doing in automation, outside of just traditional AI, that really help to clear those backlogs, and those mundane toil-based tasks that engineers don't particularly enjoy is what we can kind of alleviate and remove them from, so that they can be more innovative and deliver new features and build new applications and harness newer technologies. We must continue to go. And Modernisation is an absolute must for an organisation. It ultimately boils down to your level of competitiveness. And if you can't keep up with technology trends, then you'll find that the user experience of your offerings diminish rapidly. The ability to support them, the ability to harness newer technologies which could differentiate yourself, such as adopting AI and applying that to your systems, be it internal or external. All of these are kind of key initiatives that we're seeing across the industry that organisations must adopt. So, being able to apply those and alleviate the perspective of engineers effectively looking backwards and being able to allow them to look forwards and move, be it on those metrics that are interesting to you, be it speed or efficiency, quality, I think is a really important thing to consider. And if we can help organisations do that, and obviously we go a little further because we want to not just look at maintenance, we want to look at more transformational initiatives as well and try to harness newer technology to make that possible at scale. Because as I mentioned, organisations often have thousands of applications, hundreds or thousands. And so just having the foresight to understand what needs to be done and prioritise is a challenge in itself, let alone actually delivering the work. So these are the kind of efficiencies that I think are really important to help move the needle forward for organisations.
Yeah, no, definitely. I think it's often there's a bit of a paradox when it comes to doing modernisation from an application perspective, that the applications that are in most urgent need of modernising are often the ones that no one wants to go near because they're super valuable to a business.
Critical.
Maybe they're revenue generating applications.
Yep.
The more complex an application is, the more code there is, the more developers there are, the more time that's sunk into the maintenance of it.
Yeah.
And so trying to build the business case to modernise that application is really challenging and really scary. I think it's really easy, myself included as a consultant, right? It's really easy to go into a customer and go, let's modernise that app. And it's like, yeah, but this app is our business.
Yes.
If this app goes down, we as an organisation lose reputation.
It's like, imagine ultimately, really what we're talking about here is kind of like changing the tyres on a Formula One car as it's going around the track, right? It's that kind of situation.
Yeah.
But that's actually the reality, and that's what needs to happen, especially when you start looking at, systems that are really critical to the business, production line, ticketing systems, scheduling systems.
I can remember doing a migration with a manufacturer previously, and the metric they were throwing around for one of their critical ERP systems was like, if this app goes down, it's going to cost us £1 million an hour in lost revenue.
Yep.
We cannot afford to do that. And so the thought of doing anything other than a rehost was just completely alien to everyone, from the infrastructure manager all the way up to the execs. And so it was rehosted because the business continuity risk of modernising it was just viewed too high.
Right. And that comes down to a lot of process, not just technical process, but business process, and that's part of this, right? So one of the things that we must help organisations with is, first and foremost, a business case. How can we try and present a solid, viable business case that helps justify both things like cost and resource, the time, but also the risk, right? And you're talking about risk profile ultimately being too high, and all of this is interweaved with the fact that with a lack of visibility and awareness, there are unknowns, and when there are unknowns, there is a risk profile that is sometimes too big to bear. So having awareness, having documentation, having very clear pathways into the state of something and what actually needs to happen and how and where really kind of helps de-risk. Now, obviously, then there's the work itself, and if you've got some automation, we can apply some guardrails, and that gives us a kind of repeatability and predictability. Two key words that typically haven't been applied to modernisation in the past with traditional, manual services-led approaches. So these kind of key fundamentals are really important to help alleviate these challenges, and then we start getting into concepts like being able to effectively extract, to create digital twins, to allow us to safely, in a sandbox, start experimenting and empower the teams to experiment, empower the teams to safely make changes to an application and go through a process where they can have confidence that it becomes a bit of a light switch exercise, as opposed to trying to change the tyres on a car as it goes around the circuit, because that's scary, right?
Yeah, it's really scary. And I think we were doing a modernisation project previously, and this was fairly recent. And like their global CTO, we were like on a call going through how we were going to modernise this application, and the concept of jumping straight into an architecture phase or like a design phase where everything's essentially theoretical.
Right.
He almost did the whole Jerry Maguire for like show me the money, and just said like just show me the code, like just show it to me, build it, run it, prototype it. You know, it's almost counterintuitive to be talking about application engineering in Word documents or PowerPoint documents, and technical documentation. Like if you're going to take a feature or a domain or a component of this app and we're going to actually modernize it, why don't we just do that as a prototyping? Why don't we just take the application image, as you said, like deploy it into a sandbox, get some visibility over it, and then we can start identifying what are the interdependencies, how do we start strangling the monolith and deploying it onto a cloud native architecture pattern.
And I think some of this is, again, you know, if you look a long way back in terms of a portfolio, and we start talking about some very, very old applications, you know, COBOL, mainframe. Some of these underlying services have not necessarily been exposed to technology that at some point we might even say is almost legacy in itself, right? Virtualization and concepts of that, although that obviously has existed in the mainframe domain. The ability or inability to harness a safe haven to make changes is something that adds a lot of risk. There are some systems that are very, very specific and particular in terms of what they are dependent on, be it certain versions of a library, and maybe that vendor doesn't exist anymore. So, you know, these are the common challenges that often are not necessarily understood between business level and the technical level, and that's often a challenge in trying to bridge that gap, which is why I was talking about business case and the need for that. Because quite often, you know, again, as these applications and the environments now are evolving so much, the velocity is so high, coupled with the spread and the depth and the scale of applications that we see, it's almost an impossible job in ways without thinking about this and applying more automation to the problem. And so I have a library, there's a newer version, I need to be able to replace that dependency so that the application still functions. Maybe it's even more complicated than that. Maybe there's deprecation across some of the way that works. So these are the kind of real challenges that we see. But you're right, being able to effectively copy, extract, clone, whatever we want to call that, into a way that we could then make some changes more safely and allow us to evolve an application component or a service or a feature into something new, you know, is something that a lot of organizations are aspiring to do. They don't necessarily know how to do that or what technology is available. And so, you know, it's trying to deliver some proof points and some value to express that.
I always like to think, like, for me, cloud native is automation driven and code driven, and you view cloud as this toolbox of technologies that you're very happy testing, for using, and if it doesn't work, you just delete it and you move on. And it's a completely new way of working for a lot of sort of traditional developers and engineers, and that is where, for me, modernization is so much more powerful in public cloud, because it gives you that ability, as you said, to just rapidly test, build, deploy, understand how something behaves, and if it doesn't work, that's okay. We've actually learned a lot from doing it. Right. And like, even from a cloud practice perspective, it's like our teams, you know, if I offered them the chance, what would you rather do? Would you rather go and spend 2 months on a design project, or here's a sandbox, here's a whole load of tools, here's a whole load of scripts.
Experiment.
Have a go. What I need you to do, your task is to modernize for this metric. How you get there, as long as you can do it within these SLAs that the application requires, whether that's from a business, commercial, or technical perspective, you know, these are your guardrails. Here is your application image. Here's the tool set. Go and have a go and go and build it. And then if it works, you know, we can actually then validate that as a modernization enabling mechanism works for that application, and we can then work out, okay, how do we now take this modernization initiative that we've built, tested, and validated? How do we then start to propel that across the rest of the organization? And like at Telefónica Tech, like, we've built our Propel consulting methodology sort of around that cloud native principle of, like, let's just do rapid time to value, hypothesis driven consulting projects in the application space, where we get hands on, we show the code, we show our workings, and we validate some of these modernization options. Because there are so many ways to modernize an application. It's like, it's really challenging to know, where do I start? And so my perspective has always been that what we should be doing is just get hands-on early, start building, start testing, and show the value of the work and show that this is possible on cloud.
Right.
And Jerry Maguire it and just show them the code and just show that it's possible.
Yeah.
And if it works and people are happy, then we can start looking at how we evolve into production systems. But that, as you said, like, let's clone the app, let's modernize the hell out of it, and we'll take it from there and work out what we need to do next.
Yeah, I think for us, obviously, going a little bit deeper into that, right, it's knowing, there's two things. One, we have to understand the nature of the application, how it's been built, where it's running, how it's running. All of these are kind of artifacts and attributes that help effectively, govern pathways, what we call pathways. So given the nature of this particular application or this component of an application, perhaps it's written in Java and it's maybe Java 8 or something, how and what needs to change to allow that to run into a newer framework version. And once we've got that newer framework version, what's the optimal runtime environment? And some of these are not necessarily technical decisions, but obviously what we try to cover is the kind of technical pathways of, where the application can actually optimally move to, what needs to change, what dependencies does it have, and each of these govern the various different steps and directions that you would need to take as an engineering team. Now, if we can try and harness optimal pathways, and we can apply some guardrails and we've got some automation, then we can really break down the complex barrier and the time sink that's often spent just analysing that information, let alone actually delivering the outcomes. And then, like you say, it's based on their specific application, its roadmap, the application team, any initiative from the CTO that is kind of trying to govern the ideal target architecture and the environment that it needs to run in. All of these are kind of decisions that need to be made, but if we can add some automation along the technical pathways, then we can expedite and ensure success ultimately across each initiative. And the key point is that it should be ongoing. Nothing sits still. Applications are exposed to vulnerabilities all the time. Dependencies are exposed to new versions all of the time. So you need to also implement a process that makes that a repeatable, continuous, ongoing motion, right from understanding the state at any point in time through to what needs to change and what's the optimal way to do that to improve the application on each iteration, essentially.
Yeah, no, 100%. So my question to you then, if you were a CTO and you were sort of facing the application that is almost like a troublesome child, like you have it, you can't get rid of it,
right?
You just can't. But you're not sure how do I get this back on track? How do I resolve this? Like where would you start if you were a CTO facing that troublesome application?
I think the very popular concept of the 6 or 7 R's, whatever your flavour of choice is, initially still plays true. So high level classification of where are we trying to, what does good look like? What is the optimal pathway for this application? What are we trying to achieve? And that might be a very bigger question because it might be that there's other applications involved in that decision matrix. But essentially we're trying to understand, does it need re-architecting? Does it need refactoring? What is the language that it's currently written in? Does that actually have a future? What about its performance? Why is it a problem child? Is it performance? Is it exposed to vulnerability issues? Do we have support problems? Are there parts that are end of life? Is there a compelling event commercially that's driving the initiative and the reasons to why this is a problem? These are kind of underlying questions that need to be answered. But then I think from a technical perspective, given the nature of the application, there could be various different pathways. So let's just assume that, like we said, it's an enterprise-grade back-end service. Let's say it's a version of Java. Perhaps it's an older version of Java. So we can decide maybe our business has a lot of expertise and we've invested in a lot of Java comprehension and capability. We might want to keep it on that path. And so we're looking at this application thinking, okay, let's try and evolve this into a newer version of the framework that allows us to deploy in a certain way, and it removes a lot of dependencies on older libraries, maybe improves the security posture. Or perhaps there's even another option, which is that maybe we really want to kind of eradicate all debt, and maybe we want to put this on a different path, and so we perhaps look at an intelligent rewrite, and we want to move into a cloud-native language and architecture, and we want to deploy this and and harness serverless infrastructure so that we're really optimizing cost in a way that, just monitoring utilization doesn't really achieve. We're looking at performance. So these are all the different pathways that we can help facilitate.
It's a massive conundrum, and I think it's one that people overlook all the time, is the option of just rebuilding a new application in parallel.
Right.
Like especially if you're an enterprise that has an application that is massively complex, it's got hundreds of thousands of lines worth of code, you've got a huge developer team, looking after it.
Yeah.
And it's like how much are you prepared to invest to refactor this and rebuild it, as you said, versus how much faster could we actually rebuild an application in greenfield. And I remember working with a CTO previously, and they had a revenue generating application that was serving advertisements.
Right.
And they felt that it was, the modernization business case, there was a better ROI on actually building a new app in parallel.
Sure.
Because they were able to skip a lot of those modernization pathways and then basically rebuild it onto a cloud native application architecture, and in a way that brought the developers with them as well. So
Sure.
the language didn't change, but the actual application architecture, aside from the code base, was refactored. It just the thing evolved. And as you sort of said, like, it started with having that fairly
initial
tough,
assessment.
Exactly, a conversation around what are we actually modernizing for, and then can we get visibility? Because I think they started using some tool sets to scan the application, understand all the vulnerabilities, understand all the interdependencies, and went, wow, this is a massive big ball of mud.
Right.
So try and break this monolith down into a modular or an event-driven architecture, and create, extract some of our code base and containerize them so they are independently executable business processes.
Right.
I don't want to do that.
It could be, and again, dependent on the age and the complexity involved and various other attributes like we've talked about, like capability and resource availability, budget. It could be that in some cases, it's more viable to rewrite. Now, interestingly, that pathway has traditionally been quite locked and gated behind the fact that it's incredibly costly and very expensive, and often sometimes very disruptive, unless we're very careful about maintaining the user experience, because it could involve training and retraining. It depends on the nature of the application. But I think given the nature of how things have evolved and the core capability of how, for instance, we built our technology, we're able to achieve some of these outcomes that wouldn't have necessarily been achievable before in such a timely, low cost, repeatable way. And so options like that are certainly way more realistic than they were before.
We've been able to move so much faster, like using AppFactor for some of the projects, because it just means that you get such an accelerated visibility into the application, and to start actually identifying, that's how we should modernize this component. This is a viable modernization pathway now.
Sure.
And it eliminates so much of that sort of like manual toil, guesswork.
Manual toil.
You don't want to be paying expensive consultants to be doing that stuff. Like, let's get to the bit where we're actually building, rather than spending months on PowerPoints and stuff. I think for me, that would be, if anyone's listening to us on YouTube, that for me would be like the massive call to action. Is like, if you're facing an application that is troublesome and you're not sure what to do with it, come and have a conversation. Because for me personally, I'd love to just light it up, get visibility, understand it, get whiteboarding, get building, and then we can start coming up with some real proactive opinion and fact-based modernization pathways, right?
Right. Reduce complexity, improve time to value, move applications, and there's various different outcomes that can be achieved, right? But whether it be trying to move applications into your target architecture quickly so that you can effectively be building in the cloud, perhaps you want to do some work up front against the code base of a component before you do that. To your point, we can kind of collectively meet customers where they are, right, based on the outcomes that they want to achieve. And they can do that in a very predictable, repeatable, cost-efficient, timely way. And it doesn't have to be this complex Big Bang cycle that doesn't really move the needle. It's just delaying the problem again. One of the things that we touched on earlier was that the scale of the problem. The customers that we've been working with have, thousands, tens of thousands of applications in some cases. So trying to apply those traditional approaches against the scale of that problem, it just doesn't work. And quite often, the analogy I use is almost like the rings of a tree. If you look across the portfolio, you'll often find markers of points in time where they've delivered big bang cycles every 4 or 5 years, but they've had to leave behind.
Yeah.
And so, it doesn't have to be the case where we leave applications behind. It doesn't have to be the case that we necessarily need to perform transformation, every day. Of course not. But there is a balance between the maintenance that's required, which often is on a daily basis, and then if you've also got the toolkit available to you that you could make transformational change just as easily, really I think that puts organisations into a position where they're breaking free from the burden of debt, which compounds over time, It costs a huge amount, it really constrains, and that, coming back to your original point, allows customers to pivot the way of thinking, focus more about adding value and being creative. Our engineers should be creative. They shouldn't really be burning their time filling gaps in documentation or handling just the routine tasks that we can leverage some tooling to do.
Yeah, I think the final thing I sort of wanted to touch on was, of course, you can't sort of have a conversation without mentioning it, but like AI, and I think there's a lot of organisations we're working with who are doing really cool and sexy AI work in the new world. You know, this all cloud-based AI, that the data platforms and AI models and things that they're building, but it's all sort of like greenfield. You know, it's all built in a cloud-native manner from day zero. So everything's working the way that they designed it to, because it's essentially a baby. And now they're sort of hitting that point where they're looking behind the rest of their, as you said, like the other tens of thousands of enterprise or legacy applications they've got, and thinking, okay, we've now built this amazing cutting edge, bleeding edge technology. How do we create that compatibility and the integration between the new AI-driven, AI-native world versus the old sort of enterprise application space? How do we bridge that gap and enable these systems to actually talk with each other? And so if you want to infuse AI into your full application ecosystem, that's where you have to start modernizing each of those apps, because if they are just complete big balls of mud that you are completely unaware of how it functions, to then try and take that towards an AI system is just going to cause you risk problems.
I mean, look, effectively what we have is a situation where most software in the world already exists. And so a lot of existing systems in the enterprise, in businesses, was built in a point in time before AI, before the emergence of what we're seeing at the moment, and before the means of being able to integrate, and effectively expose data in a safe way and be operable from an LLM or agent workflows, whatever it is that you're trying to achieve and that you've built or you're looking to build. Now, you're kind of touching on one of the capabilities of our product as well, which we're shortly about to release, which really allows rapid integration without any code, without any change, in a central way, to allow systems that were built before the emergence of AI and allow them to bridge into a world where they can effectively be pulled into the era of AI without any integration. And really what that means is that their data, their functions, the tools that their APIs expose can be effectively bridged into something like MCP, and rapidly then made available to agentic workflows or LLMs, so that you can really expose that data securely, centrally, with enterprise level controls and features that really kind of brings these older systems into the world of AI, be it mainframe, be it older systems that you've got in your environment. We're
seeing a massive rise in people trying to build out agentic workflows across their application space, and like one of the things we've spoken about is having really talented developers stuck doing the routine or mundane tasks within their application lifecycle, and it's like, okay, well, how can we, as you mentioned, like integrate agentic AI into that traditional application space?
They were never built for AI, right? So if you start picking away at this problem, you realise that there are many APIs available, and you might have SOAP, you might have gRPC, you might have GraphQL, you might have OpenAPI, you might even have some APIs that don't conform to the OpenAPI spec. That's the real world that we live in. Now, you don't necessarily want to go back. Maybe some of these APIs you were never even given the source code for because it's a third-party system. But you want to harness AI against these systems and against the data and against the functions that those APIs deliver. So what if there was a way of really safely, without any integration, without any code required, integrate those to make them discoverable? Now, we have the way of really elevating those tools that are provided through the API and augmenting and adding metadata to allow them to function at a higher level in the world of AI so that they can be better utilized and optimized for LLM integration. That's what we're talking about bringing to market, but also doing that in a central way. So one of the other problems that we have as organizations race to experiment with AI and race to adopt AI across their environments is this huge sprawl of MCP servers that are cropping up. And there's almost like this repeat again of this kind of shadow rogue IT happening where CISOs and other teams are kind of like scratching their head and a bit concerned at the pace of this code that's emerging, that's creating yet more footprint and surface area to maintain is one thing, right? But also the risk associated with that. There's a lack of awareness and visibility about what data is actually traversing, what server is actually communicating with this system. So there's a way of centralizing this and governing it, adding some policy and controls, but enabling it in a safe way without having to build all this bespoke code to maintain. Then I think that's a real powerful way of making this possible.
Like we've definitely seen like a massive acceleration, right? Like the pyramid of people now who can write code and ship code and build applications. Mm-hmm. Now that pyramid is exploding with the ability of like new tools and new workflows that make it's never been easier to build an application.
True.
But with that comes, as you mentioned, like the business continuity risk that potentially people are shipping code which they don't fully understand.
Yep.
They are shipping code which potentially create unknown attack surfaces or expose unknown sort of network components.
Yep.
And so, yes, you might be moving faster and shipping more code and writing more code, but is that then actually creating
problems
a negative flywheel where, yes, you're running faster now, but that's going to be at the expense in maybe 2 or 3 months where you're going to face the massive mountain of technical debt. And I think maybe before the advent of people using AI to write code, it maybe took you longer to hit the inflection point from a scalability perspective where you struggle to scale your system because you had so much tech debt that you were trapped in that maintenance and operation cycle. Mm-hmm. And I think that moving forwards, with more and more people just writing more and more code through AI, I believe that people will hit that inflection point much earlier where suddenly they've built an app which, yes, it does that function that you required it to, but if you now want to continue to scale it, it's actually not written in a way that's going to enable you to scale it. Yes, it works as a prototype, but as a modular component that's independent and scalable, it's not. It's got too many interdependencies. It's reliant on that runtime. It's reliant on a code base which you don't understand. And it's reliant maybe on a library which is actually exposed or already out of date.
Lots of challenges.
Because you're not sure and you haven't maybe considered all those factors, like, yes, you've built a working prototype, but no, that working prototype won't ever make it into production.
Yeah, there's lots of challenges with this. I mean, there's at least from a business perspective, when we look at enterprise and small, medium enterprise, there's a number of steps that are kind of missing a lot with the kind of vibe approach, which is some design factors. So what language are we actually going to pick and why? What is the reason that this service or this feature or this functionality exists? And that can help define the language that we choose for reliability and resilience and security posture. That concept of design principles is something that is often overlooked with a prompt, where it's then effectively making decisions on the libraries that it chooses, and it's not necessarily governed in the sense of, hey, pick something that's very secure, pick something that's really, really reliable. Where's the source even of this dependency? And these are the kind of things that are overlooked, which is allowing, it's an incredible thing, it's allowing organizations to move super, super fast and prototype and experiment and go through those cycles incredibly quickly. But agreed, there's also the question of what does production really require and what does production look like? And production, of course, is not a full stop. Production is something running that's delivering a service, be it internally or externally. And therefore, what are we doing to actually maintain that? How does that evolve? And that's where we start to get in a challenge, especially when some of those decisions or the conception of that service has been built in such a way where we haven't factored these things in, we haven't documented these things. The LLM isn't necessarily exposing its thought process that would help us understand the rationale around some of its decisions. All of this effectively could lead to significant technical debt, and that becomes a bigger problem later. And that's, when we were talking earlier about the scale of the problem, really this is exponentially exploding, this technical debt challenge is really now outpacing the speed in which we're able to remediate. And that is really the underlying problem with this. So the reason we exist is to we recognise that problem. We've lived and breathed this problem for many, many years, a couple of different products. And we're very passionate about solving this problem. We can see this mounting, emerging and growing, kind of like lava setting out of a volcano, right? It's kind of piling up. And the speed in which that's happening is exponentially growing. So we've got to try and tackle this problem head on. Yeah. And making this a continuous motion, I think, is the very key. Having that awareness and that visibility to try and unpick what's being created or what already exists. And then having that toolkit that helps make that an ongoing motion is something that we really, really need.
Brilliant. Absolutely amazing. Thank you so much for
no problem. Pleasure.
me. Thank you so much for talking it through. Sure. Thank you for listening to Keith and myself talk about application modernization, application engineering, and where to get started. If you're facing troubles with your application portfolio, or you've got a troublesome application that you're really driving to modernize, reach out, let us know, check out our website, and if you're keen to see a demo of AppFactor in action, I can promise you it is pretty cool stuff, then let us know and we'd love to be in touch with you.